Kia ora Year 12 and Year 11. This is another question from the summer 2015 paper. This one is a nice differentiation and trig example where you have to solve a little trig equation and then identify some stationary points. So here's the question. If you've just watched the trapezium rule problem, this one's a little bit harder. This is worth 7 marks, so you've got to expect to be doing some work for that. So we're given the equation of a curve, and this is it here. So y is 3 cos 2x plus 7 sin x plus 2. And we have to find the x coordinates of the stationary points in this interval. So that's good. We don't have to find the points. We just have to find the x coordinates. And we don't have to say if each one is a min or a max or anything like that. So most of the work will be in differentiating. So first we're going to find dy by dx. And we're going to set that equal to 0. We're going to solve that equation, and that will give me the x coordinates. And that's about all there is to it. So let's get going. We've got dy by dx is equal to, right, we have to do the chain rule on this. So it's going to be 3 times 2 sine 2x, but we need a negative sign, right, because cos differentiates to give me sine. This 2 is here because I've got a chain rule thing. This is my inside function. So if I still need to, I could write that as 3 cos u and do the long drawn out version of the chain rule. I think most of you are probably past that point now though. So that's the first bit. So negative 6 sine 2x. The next bit is easy. It's plus 7 cos x. And the plus 2 differentiates to 0. And that equals 0 for a stationary point. And we should write down what we're doing there. So solving that, what do I have? Well, I've got negative 6 sine 2x plus 7 cos x is equal to 0. I'm going to use the double angle formula on this. I get negative 6 2 sine x cos x plus 7 cos x. So why did I do that? Well, I've got a cos x here and I've got a sine 2x here. I don't like that. I want to have all cos and sine of x. And here I can see that I get a common factor of cos x. So we're going to take that out as we clean things up, and we get cosine of x times 7 from this term minus 12 sine x is equal to 0. So the stationary points will happen when one of these things is true. Either cos x equals 0 or 7 equals 12 sine x. And we're looking for solutions between 0 and pi. So just quickly, as usual, sketching, I can see that here there's only one solution, which is that x equals pi on 2. And here I need to solve 7 over 12 is equal to sine x. Now let's draw a quick sketch of the sine curve. See, all of that work you guys did on level 3 trig is paying off. Here's my sine curve. I'm interested in this bit here, just from 0 to pi, and I'm looking for the intersection with 7/12. So I'm not going to use general solutions or anything crazy like that. My first value will be x is equal to sine inverse of 7/12, and that's going to give me 0.6228. Now I've got to round that, but I'm not going to do that quite yet. That's the first value here. The second value is going to be x equals pi minus that value. So that works out to be 2.5188. But just notice the rounding that I've been asked for in that question. Right, I've got to give each answer correct to 3 significant figures. So we do need to go back and round both of those. This one, I'm sure we can leave that as pi on 2. It pains me to do this, but I'm going to write this to 3 significant figures, and I get x equals 1.57 to 3sf, or x is equal to 0. What do I want? 3 significant figures, 622, or x is equal to 2.52. Now that's all we're asked to do in that question, so that's the 7 marks. Just think about how that question could be extended. The 2 obvious ways are if you were asked not to find the x coordinates, but to find the stationary points. And if that were the case, you'd have a bit more painful work to do. You'd have to go and substitute each of those 3 values in there. And then the next thing you could do is be asked to figure out, for example, which of those values was a relative maximum, and then you'd have to go and check the second derivative. And it's not too hard, it's just a little bit more mucking around. So that's all for that question. Thanks for watching. I'll be back with a couple more later on.